The year is 2003. In Iraq and Afghanistan, forward operating bases rise quickly, plywood cities built for speed, not safety. Soldiers sleep behind thin wooden walls, a fragile comfort in a war zone. Mortars, RPGs, and IEDs turn these structures into death traps. Wood shatters, sending splinters flying like shrapnel. The enemy knows this weakness, targeting bases to inflict maximum casualties during moments of supposed safety. A single blast can turn a barracks into a slaughterhouse, not just from the explosion, but from the catastrophic failure of the building itself. Commanders face a grim equation: build fast and risk lives, or slow down and lose operational momentum. Traditional fortifications, sandbags, concrete, steel, are too slow, heavy, and impractical for the scale of the conflict. The military is desperate for a solution, something fast, light, and strong enough to save lives. The answer must come quickly. Thousands of lives depend on it. The military turns to sandbags, reliable but slow and exhausting to deploy. Concrete and steel offer protection, but are too heavy and logistically impossible for rapid deployment. Supply chains are already stretched. Moving tons of material isn't feasible. Advanced armors are expensive and complex, unsuitable for field use. What's needed is a lightweight, easy-to-apply solution, a kind of armor in a can. The real killer isn't just the projectile, but the deadly splinters from shattered wood. The breakthrough won't come from traditional armor, but from an unexpected civilian product, waiting on the beds of pickup trucks. Enter Polyurea, a spray-on coating best known for protecting truck beds. Originally designed to prevent scratches and rust, it forms a tough, flexible skin in seconds. Someone in military R&D asks, if it can protect a truck, can it protect a soldier? The military tests it on plywood, the same used in barracks. Uncoated wood shatters under fire. Coated wood stretches, absorbing the impact. The polyurea acts like a catcher's mitt, containing splinters and localizing damage. Even if a projectile punches through, the wall doesn't explode into deadly debris. The result: a lightweight, rapidly applied shield that transforms fragile walls into life-saving barriers. The humble truck bed liner is about to change the battlefield. Polyurea is an elastomer, flexible, strong, and fast-curing. Sprayed onto wood, it bonds instantly, forming a seamless, durable membrane. When hit by a blast, its tensile strength spreads the force, while its elasticity allows it to stretch and absorb energy. Instead of shattering, the coated wall bends and holds together, preventing lethal splinters. Even if the wood behind is destroyed, the polyurea membrane contains the chaos. The goal isn't an unbreakable wall, but a wall that fails safely, protecting those inside. This simple shift from brute resistance to controlled failure revolutionizes battlefield protection. Lab tests are promising, but real proof comes in Afghanistan. Polyurea, under the name Paxcon, is sprayed onto barracks and guard towers. The process is quick. A building can be treated in hours. Soldiers are skeptical, but soon a grenade lands beside a coated barracks. The explosion would have been deadly. Instead, the wall bulges, but holds. The polyurea absorbs the blast, catches shrapnel, and prevents splinters. Soldiers inside are shaken, but alive and uninjured. Word spreads, demand for the coating skyrockets. It's used on vehicles, government buildings, and bomb disposal sites. The truck bed liner becomes an unsung hero, saving lives in the world's most dangerous places. Polyurea's success in war sparks civilian interest. Its blast mitigating power is adapted for safe rooms, panic rooms, and disaster shelters. Spraying polyurea on walls turns ordinary rooms into protective havens against intruders, storms, and flying debris. Building codes change. Schools and hospitals in hurricane zones adopt the technology. Bridges, pipelines, and chemical plants use it for added resilience. What began as a truck bed liner now shields critical infrastructure and homes. Innovations born in conflict can protect us all, bringing battlefield resilience to everyday life. Polyurea's story teaches a vital lesson. True strength is about managing failure, not just resisting it. Like safety glass that cracks but holds, polyurea forces brittle materials to fail safely, not catastrophically. This is the essence of resilient design, predictable, survivable failure. For preppers and builders, the takeaway is clear. Prioritize flexibility and controlled failure over brute strength. The soldiers in Iraq and Afghanistan were saved not by thicker walls, but by a thin, flexible coating that changed the rules. In survival and innovation, resilience, not invincibility, is the ultimate shield.